I'd like to tell you about the motorised turntable that I've got on my Hornby Dublo 3-rail layout. It's a Marklin electrified turntable from the 1950s, but it exactly matches Hornby Dublo track, which can be plugged straight into it. I use 5 outlets which feed the engine shed and 1 inlet. The turntable is controlled with a DCC controller, and the 5 outlets correspond to the first 5 addresses on the DCC controller. So to send the turntable to address 1, I select address 1, and then depending on which end I want to send to the engine shed ends, it's either the cabin end, which is there, or the non-cabin end, which is the straight setting. The turntable is set with the non-cabin end to position 2. If I select 1 on the DCC controller and send a straight command, then the turntable moves to position 1. If I send position 3 and then send a straight command, it moves to position 3. Note that it skips position 2. And ends up at position 3. If we want to align the turntable with the output track, then we have to align T to 1, and we do that by selecting 1 and turned. Note that it takes the shortest route to achieve this objective. Skips output 4. And another unused output. And stops on 1. The control electronics works on a dead reckoning basis. It counts the number of outlets that the turntable passes until it reaches its wanted destination. And those outlets also include outlets that I'm not using, but it has to count them anyway. The alignment of the tracks is very clever. There's a spring-loaded plunger which goes into a hole in the centre of every track. And there's a solenoid which pulls that plunger out to allow the turntable to move when the motor is energized. The motor driving the turntable is a DC motor with 2 field coils, one for each direction. I use a PIC microprocessor to control the electronics, but of course you could use equally an Arduino. Here's the very simple circuit. The 3 coils are common to the 0-volt rail, which is the turntable metalwork, and the coils are switched by 3 MOSFETs. The motor coil current is detected with the resistor R2, and this enables us to detect when the motor current drops to 0 when the turntable reaches one of its tracks. That motor current voltage is fed into the PIC GP4. The power supply is at -16 volts, and that's because the track is at 0 volts and we need a voltage below the track base voltage of 0 volts in order to switch the coils on with FETs. The DCC signal is fed to the PIC via R1, and the PIC is powered by a 5-volt regulator. Here is the algorithm that the PIC uses to direct the turntable. There are 16 possible turntable positions, of which 10 are actually used. The starting position is labelled S and the destination is labelled D. And the algorithm tells the PIC how many steps the turntable must move to reach its destination D from the starting position S. You can find full details of the design in the MERG Journal for September 2020.